Welcome back, Terraformers. And I just want to talk about where we're trying to go for pre-week. What I want to have set up is I want to be using managed remote state in Terraform Cloud. I want us to have some very simple AWS resource so you can use the validator within our platform to get comfortable with that. I want us to do a init, plan, apply, and so that's what we're working towards, okay? And in this video, we're gonna focus on using Terraform Init and setting up our first provider. I want to not necessarily do AWS in this one, but I want to introduce you to the Terraform registry website and talk about how to configure providers. So I'm at my repo here, and we're going to, before we do that, create a new issue. And we'll create a new issue here, and we're going to set up Terraform randomness, random bucket name. So what we want to do is generate out well, first of all, we want to explore the Terraform registry. Another thing we want to do is we want to install the Terraform random provider. We want to run Terraform init. We want to generate out a random bucket name, which we're going to do. And from that, I think that is enough because in another video, we'll want to do plan and apply. Then we'll want to do Terraform Cloud. We'll want to do S3, okay? So we'll keep those all a bit separate and keep the scope small. So this is all I really want to do here. We might want to output the, sorry, we might want to output the random bucket name to outputs because we need some way of actually seeing it. So we'll be learning about outputs a bit sooner than we want to. So I'll go ahead and create that ticket. And what we'll do, and my head is in the way, I'll just shrink it out of the way or move it over here for just a second. We're going to go ahead and create that branch and say checkout locally. We'll close that out. We'll go to our top here, move my head back over to the corner here. We'll drop down and we'll make our way over to 9 Terraform random bucket name, and we'll go ahead and launch that Git pod environment. So we have been fiddling with the environments quite a bit, so we will just double check, make sure our environments are working as expected. But yeah, in this video, we don't necessarily need to use AWS. We'll use that in a future video here shortly. But our environment is launching up. Let's make sure that those are working. We'll give it a moment to think. That one looks like it installed, no problem. Except here it says the security token included in the request is invalid. That's because I rotated out my credentials. I deleted them, so that is expected. So that is not a problem for me. For you, you probably wouldn't get that error because you're not clearing them out like I am. But that is totally fine. Over here, it looks like Terraform is now installed. I'm going to bump this up a little bit so we can see what we were doing. Bring this back over a little bit. And so what I want to do here is show you the Terraform registry. So we're just going to type in Terraform registry. And this website is registry.terraform.io. This website is a website you need to remember 100% when working with Terraform. This is where we get providers. This is where we get modules. So there's other things in here, but those are the two ones that I'm familiar with. See, it says policy libraries and run tasks. I don't know what those are. I'm Terraform basic here. Directly integrate third-party tools and services to manage cost, security, compliance. Sounds really good, but I'm not familiar with those as of yet. I just know these two, which is providers and modules. It's important for you to understand the difference between providers and modules. Providers is the way you directly interact with an API to make it powered by Terraform. So if we click into providers, you're going to see things like AWS, Azure, GCP, Kubernetes, Alibaba Cloud, Oracle, and a bunch of other ones. So these are, again, it's a mapping of like AWS's API to be utilized within Terraform, if that makes sense. So if we go into AWS here, I'm going to click into it. We can go up to the documentation here. And what you'll see here is all these things. So we're going to end up using S3. So I'm going to just type in S3 here if that will let me finish writing that in here. And so our provider allows us to write resources and code, okay? It defines, it's a mapping of the API to resources and things like that. So let's talk about modules for a moment. A module is basically, it's a collection of Terraform files, but basically it's like a way of providing a template to utilize commonly used actions. So over here we have Terraform AWS modules IAM or VPC. So we go over here to the VPC one, which is by Anton. I know Anton, great fellow. But if we drop down examples and we take a look at something like manage default VPC, and we scroll on down here, we will see an example. I'm just trying to find one here. Maybe this one here. Why am I not seeing the example code? Show me example code. Come on, Anton. I know you got example code around here. Well, let's click here for an example. Well, I'm not sure why I'm not finding examples easily here today. I'll go back up a layer and see if that helps at all. Right, and so the idea is that modules, basically, if you write a lot of Terraform code with a provider, you can turn them into templates. And so in here, it's specifying a source, which is a Terraform AWS modules VPC AWS, and then you can provide this top-level configuration. But if we go actually inside of this, which is Terraform AWS modules VPC AWS, so that'd be, there should be folders or something like that here. Modules. Well, not exactly working as expected, but my point is that you go inside, that module will contain a lot of Terraform code. So we are going to write modules in this bootcamp. If it doesn't make sense right now, don't worry, it'll make sense later on. I know it's not easy to understand at this point in time, but I just want you to remember that modules are templates. It makes things a lot easier, portable, to move a lot of Terraform code around. Providers are the interfaces, direct interfaces to APIs for providers, okay? So we are going to be working with first the random provider. And if there's an API, you can make a provider for it. In fact, in this bootcamp, we should probably be making a provider, which is something that's really hard to do, but I'm going to walk you through it because I think that'd be really cool to do. But there's one in particular that I'm interested in. It's called random. So if we go here, we have the HashiCorp random provider, and this allows us to randomly generate things out. So I'm going to go here to documentation. So the random provider allows the use of randomness within Terraform configurations. Generally, they say don't use it if you don't have to, but we're going to use it because we are learning. And if, the way it works down below is that we create a resource, and that's going to generate out a random value, and then we can access that value over here, if that makes sense. Okay? So that is the idea there. But let's go ahead and see how we can install this. So coming back over to our code, and I realize that was a big mess of stuff, but don't worry, it'll make sense as we work through it. But we have this main TF file, okay? And what I want you to do is go over here, and we're going to use this provider, and we're going to go ahead and copy and paste this code. Okay. So remember I was talking about modules. In fact, when we are writing Terraform, we actually are writing a module right now. If you make a main TF file, that is a top level or root level module. We'll talk about modules later, but I just wanted to point out that we are making modules all the time. And so we need to provide, in the Terraform block, we have to say we are going to require this, this provider, which is at HashiCorp random. And then if we need to configure it, we can put any additional options. So this is pretty common when setting up providers. So that is straightforward. Then we need to provide a resource. So here, this is an example of a resource. And we said this is going to be for a bucket name. So again, I'm just copy pasting that in. And it's going to generate out a random ID. And then we name what we want to call that random ID. So I'm going to call this bucket name. Okay. And I don't exactly understand what these keepers are, but down below here, it's obviously we can specify the byte length. But let's go over to the resources on the left-hand side, and this gives us a few options. So we have random ID, random integer, random pet, random string. I think we want a random string. So we'll go over there. And so here we have example of a random string. So I'm going to go ahead and copy that. and we'll paste that on in here. Okay. And we're just going to say bucket name. And we can say the length, the special, the override special, and we'll read a little bit about this. So this resource does use a cryptographic random generator. That is great. Let's scroll on down below. Length, the length of the string desired keepers, an arbitrary map of values that when changed will trigger a recreation of the resources. So we don't need to recreate anything. We don't have any keepers right now. We'll do that in a future video. Min lower, lower, min numeric, override special. Supply your own list of special characters you use for string generation. The overrides the default character list and the special argument. And these are the special ones. I don't want to use any of these because this is we are using an S3 bucket name. So I'm just going to go and take all of these out like this. And so I'm going to hope that generates out a random random value there. And so what I want to do is I want to output this value. So I want to see if I can do that somehow. And it looks like we do. We have ID or result, the randomly generated string, or the generated random string, the generated random string, or the generated random string. So I'm not exactly sure what the difference is between these two. It's not making a total amount of sense. But we're going to want to place out outputs somewhere here. So I'm going to put in outputs. And let's look up how to do outputs. Outputs Terraform. And we'll go over here and look for an example. So it's as simple as that. So I'm going to go here. And again, I'm not explaining a lot right now because this is pretty weak. We're just trying to get something working and set up. And then in future videos, I'll be a lot more descriptive, okay? Right now, all I want you to do is copy and paste and do your best to follow along, okay? And so here we have an output, and I'm just going to call this random bucket name. And I'm going to go up here. I'm going to say random string. And I'm going to say bucket name. And I'm going to choose ID. I don't know what the difference is, so I think that's going to choose what I want. Just if it's not clear, I'm going to do result because I can't tell based on what it's supposed to do here. So I'm going to just do both of those. And so we now have two different outputs here. And special, actually, maybe we can just say special false. Go back over here. Let's read what that does. What does special do? Include special characters in the result. Okay, so we can just say false, and then I can take that out. Okay, and hopefully that will generate a safe value there. So let me just triple check here. Okay, great. So now we have some code. And the first thing we need to do in every single Terraform project is we have to type in Terraform init. That's how you initialize a new project. Notice on the left-hand side, you do not see any additional files over there, but we are in the Terraform tab. It doesn't matter if we're in the AWS one, but we're going to do it from here. And so what I want you to do, before you type in Terraform init, we're going to type in Terraform and hit enter. And what we're going to see here is a list of options. So we can read here and it says init, so prepare your working directory for other commands. So that is the first thing we're going to do. And yeah, we really do want to cover all these main commands before we start the bootcamp. But let's go ahead and run Terraform init. And so it's done a few things here. Notice there is now a .terraform folder here. And we're going to scroll up and take a look at what it's done. So it says initializing the backend, initializing provider plugins. So finding HashiCorp random versions matching 351, installing it, and now it's been installed. Terraform has created a lock file, .terraform lock HCL, to record the provider selections in selections it's made above. Include this file in your version control repository so that Terraform can guarantee to make the same selections by default when you run Terraform init. Okay, success, you are ready to go. You can do a Terraform plan. So what has happened? It's created a .terraform file. It's created a Terraform lock HCL. If you've used any kind of programming language like JavaScript, you've probably seen the package lock files. If you've used Ruby, you've seen gem block files. You know, for a variety of those, say they are locking in the versions of things that you're using. So over here, we can see that we're locked in to use HashiCorp Random from the registry terraform.io. Okay, and it's providing some hashes, whatever that means, and its exact version. When you do the Terraform certification, one of the exam questions is, what is the address of, I mean, at least it was when last time I did it, was what this is. So try to remember what this is, registry.terraform.io. That's important to remember. The other thing is that it created this .terraform folder. This is going to contain, I believe, the code. Yeah, if we open this up, notice it's too large of a file and we can't open it. It actually downloaded the binary for this provider. Terraform providers is written in Go, the language Go, and they're compiled into binaries. And so you're downloading a binary from the registry, which is that we're talking about there. Okay, we don't have to write Go, or at least not right now. We will do that way later in the course. And don't worry if you don't know Go, you'll be totally fine. But that's what it's doing. It's downloading and putting in this folder. We do not want to commit this folder to our repository. This gets initialized every time we do that and provides it there. So in your git ignore, make sure that you are ignoring that folder. When I set up the template project, I told GitHub to choose to set this up as a Terraform project to add all the stuff in here. So notice we're ignoring the Terraform directory. We're going to ignore the TF state, which we've yet to see. We're going to ignore TF vars, which we'll learn about passing along variables. The Terraform configuration file, which is like a configuration file for Terraform, and some overrides, okay? Coming back over to here. So we have this, and it said we are ready to do a plan. So let's see if we can do a plan. Okay, so we'll go and bring this on over here. Just again, trying to make this easier for you to see. And let's go ahead and try and type, whoops, we'll type clear here and type Terraform plan. And we'll hit enter. Okay, so what has it done? So Terraform plan is creating, I believe, a change set. So in infrastructure as code, a change set is basically a file that says, this is how we found the resources to be, and this is what we plan on changing. And so basically you're creating a plan to what you are going to execute. And so here it says, Terraform used the selected providers to generate the following execution plan. Resource actions are indicated with the following symbols, plus create. Terraform will perform the following actions. It's going to create this resource, and it's going to create it with this configuration. Going down below here, changes to output, so we can see that it's going to create these output. It doesn't know what they are yet. It has to generate them out. You didn't use the -out option to save this plan, so Terraform cannot guarantee to take exactly these actions if you run Terraform apply. So that's what I mean, is that if you do -out, you can save it to a file, and that will save your plan and execute it, but we don't need to do that. So now we didn't have any issues here, so this is where we're going to see if we're going to have any issues. We don't. And so we are now ready to do Terraform apply. And so what Terraform apply is going to do, it's going to run plan to generate out the plan, and then it's going to execute it, which is the second part of the apply. So we'll go ahead and hit enter. And what is it doing? It's asking us to enter a value in. So let's take a look. What does it want? Do you want to perform this action? Terraform will perform the actions described above. Only yes will be accepted to approve. So when you run Terraform apply, it's always going to ask you, are you sure you want to deploy? Are you ready to do this? Yes or no? And we are, so we're going to write yes. There is a way to automate that. We'll talk about that later, but we're going to go ahead and hit yes. And what it has done, it says, okay, applied complete, resource 1, and it's generated out those things. And the value is the same. So when we were reading the documentation, it said this is the random generated string, ID result. Why are they different? I don't know, but they are the same, so we don't need both. So what I'm going to do is just clear that one out. And I'm just going to do this. I'm going to stick with the result. I kind of prefer that. And so now we have changed our code. And so I'm going to type in clear here, and we're going to do a Terraform plan again and see what happens. Okay, and what does it say? It shows that there has been a change. Okay, so ID and result are going to be removed, and it's going to change this to name. There are things that matter when we change resources, whether they might replace them or create and update them or things like that. We'll worry about that later in the course. Right now, we're just going to observe that when we do Terraform plan, there is some kind of change happening. So we're ready for that. I'm going to do Terraform apply. I'm going to type in auto approve. That is the way we automatically approve it. So we don't have to type in yes. We'll go ahead and hit enter. It's made the change. Notice that it's outputted our random bucket here. We can also, if we type in Terraform, if we forgot what it is, we can get the outputs another way. So I'm just going to open this up. And somewhere in our commands here, we should have output, right? So if we type in Terraform output, it will output all of our outputs, which we only have one. But we can type in Terraform output, and I'm going to say random bucket name, hit enter, and that's going to output that value. Okay, so that's all I really wanted to achieve in this video. Let's do some documentation because I want to make sure you're good at that. I think probably what will happen is at some point in this course, I will stop documenting and start to ask you to do it on your own. But for the start of pre-week, I'm definitely going to be doing documentation with you here. Let's go all the way to the bottom and save some resources. So this is basically about basic action. So Terraform basics. We'll go here. So we'll talk about the Terraform registry. So Terraform registry. Terraform sources their providers and modules from the Terraform registry, which is located at Terraform or registry, terraform.io. And you might be tempted to use ChatGPT to, and you can, to some degree, help you write your notes, but try to write your own notes because then you'll understand, you're better remembered. Or if you generate out ChatGPT, try to modify it as much as you can to make it better. And so that should hyperlink, but if it doesn't, I'm just going to go ahead and do it this way. And we'll go grab the full link here. Okay. And so we have providers and modules. So modules, providers are interfaces to is an interface to APIs that will allow you to create resources in Terraform. This is what I'm writing because this is what makes sense to me. If this doesn't make sense to you, read a little bit about providers and make a definition that makes sense to you that you'll remember. It doesn't have to be perfect. You just have to have a general idea what it is so that you can execute it. In my Terraform certification course, I spent a lot of time defining it correctly. So if you want, you can go look for that video. But again, I'm just trying to write it off the top of my head and try to use my active memory as opposed to making it perfectly textbook. Modules are a way to refactor or to make large amounts of Terraform code modular, portable, and shareable. Okay, so that's the one thing. So Terraform registry, this is providers versus modules. We learned about Terraform console. So here we can say, we can see a list of all the Terraform commands by simply typing Terraform. We can talk about Terraform Init at the start of a new project or a new Terraform project, or when we have recently downloaded, Terraform project, we will run Terraform Init to download the binaries for the Terraform providers that we'll use in this project. We go up here and just give an example of providers. So this is the one that we use. So We'll go here. And we might just take out this part here and just say random Terraform provider. Okay, so there's more to write. So like there is the, we did Terraform Init, Terraform plan. This will generate out a change set about the state of our infrastructure, and what will be changed. We can output this change set, i.e. plan, to be passed to an apply, but often you can just ignore outputting. Okay, we have Terraform apply. This will run a plan and pass the change set to be executed by Terraform. Apply should prompt us. Okay, we'll go up here also and just say like Terraform plan here, Terraform plan. Apply should prompt us yes or no. If we want to automatically approve an apply without having automatically approve apply, we can provide the auto approve flag, e.g. Terraform apply auto approve. Okay, so there's that. We have our Terraform lock file. We didn't talk about Terraform state. So when we ran Terraform apply, it generated out a Terraform state file. If you look inside of it, it's very simple. It tells us the version of Terraform. I believe this is the version of Terraform we're using. I don't know if this is version 4 or it's the provider. I'm not 100% sure here. Terraform version is here, 1.5.7. Version 4, I'm not sure what that is here. Maybe it's the syntax of the state file. I'm not sure. We have output, so we have the random bucket. Down here we have the resources. So you can see we have mode managed, type random string, name, bucket name, the provider that it's using, and all of its configuration. In practice, you do not fiddle with this. Okay, so this generates it out. You should not go in here and change this stuff ever. There is rarely no case where you should be doing that, but if you ever want to read it and just see where the stuff is, you have it. When you generate it out, it will create a backup file. So the next time you generate the next one, this should be the last version. See, it says serial 2. This is serial 3. Notice that it has ID and result. This one is name and etc. Okay. So for documentation purposes, we need to still talk about Terraform lock file. And we have Terraform state files. So we have .terraform.lock.hcl contains the locked versioning for the providers or modules, I suppose, that should be used with this project. The Terraform lock file should be committed to your version control system, e.g. GitHub. Okay, then Terraform state file. This will be Terraform TF state. Contains information about the current state of your infrastructure. This file should not be committed. And we'll have to emphasize that. Should not be committed to your version control system. This file can contain sensitive data. If you lose this file, you lose the knowing the state of your infrastructure. Okay, this is what we're going to be in managing Terraform Cloud. .terraform tf state.backup is the previous state file. State. Okay, so that's that. We have this .terraform directory. So Terraform directory. Directory is another word for folder for those who are not familiar with that. So .terraform directory contains binaries of Terraform providers. Probably has other things, but that's what we're observing right now. So that's what we want to talk about. And so, we've covered quite a bit here. I think that's okay. Let's go take a look here and see how that looks. It is kind of becoming hard to see what is going on here. What we should probably do is make a table of contents at some point here, but I'm happy with that documentation. And it's okay if we lose a state file because the provider that we're using is not saving the state like on AWS. So the problem with losing that state file is if we were using AWS and we create a bunch of resources and we lost that state file, that would be a big problem because we would have to re-import the state or do a lot of work to get it back to normal. But this is just a random number locally, so this is less of an issue. Let's go take a look what it's committing because we don't want to accidentally commit something that should not be there. So we do want the lock file here. If you're not using gitpod and you see the state file here or other things, make sure you update that gitignore file. This looks good. This looks, I think, okay. And we're going to work with that. So we'll go back over here. We'll look at our issue and we'll see what we've done. We have explored the Terraform registry. We've done the random provider. We've ran Terraform init. We generate out the random bucket name. We output it there. We did plan, we did apply. Now I didn't write that in here, but we definitely did do that. So we're going to add that up here. This is for 9. So we'll say #9. So add Terraform add random Terraform provider. Okay, we'll go ahead and commit that, and we'll sync those changes. So we're in good shape here. I'm not going to close this because we always end up having to do that. We're going to go over to pull requests. We're going to create a new pull request. We're going to choose 9. We're going to bring that into main. We're going to create that pull request. We know what we did here, so I'm going to hit create. We won't do that every single time, write something here. We're going to squash and merge. There's only one, but we're going to do that. We'll go ahead and do that. That's going to now bring that over to main. We'll go back over here. We need to tag it. So we'll do a checkout. Git checkout main. Git pull, because we need to pull the latest. If we're not 100% confident, we can check our tree, which is something you should commonly do. This looks like we are up to date. So we want to tag this as the new version. Our last one was 040. This one's going to be 050. So we'll type in git tag 050 git push -- tags. Okay, we're going to go and check over here and make sure everything's okay. Back over here. That looks good. That looks good. We are in good shape. So we are done here. Let's stop our workspace. And so the next one, we are going to create an S3 bucket. Okay, so that is what we'll do next with AWS. Ciao.